we're going to look at finding the lowest common multiple or lowest common denominator of an expression. Specifically to that, we can later add and subtract rational expressions. So we're looking to be able to find the LCM of an expression so that we can find a common denominator when trying to add and subtract fractions here in a few minutes. So just like when we used to add subtractions without variables in them, you guys know that you couldn't add 2/5 plus 3/8 because the denominators are not alike. You would have to make them a common denominator using the common multiple of them, which would be 40. So in this case, we would have to multiply the first one by 8 and get 16/40ths, multiply the second one by 5, get 15/40ths, and then we can combine the tops. We have to do the same thing, only we're going to do it with variables. So like in the first one, it shows you guys that if you have a common denominator, you can just add them right away. A plus B over that common denominator. I know the second one is cut off, but it's the same. If you would have 5x squared, you would just keep the top, 3x plus 7 over 5x squared. But if they are not alike, so like in the second box, we have A over C plus B over D. So our denominators are C and D. So what happens here is the first fraction has a common denominator of C, the second one has a common denominator of D. The common for both of them would have to include them both. So what happens is if the first fraction is missing a C, or missing a D rather, it has the C, we would need to multiply it by that value that it's missing. And vice versa, the second one has the D, but is missing the C, so that's what we need to multiply by to get the common denominator for both of them. So we will add and subtract fractions, but we're first just going to practice finding the lowest common multiple. So I'm hoping it makes a little more sense once we get going here. But the lowest common multiple includes the highest number of times one factor occurs. So it kind of seems backward, like you think lowest common multiple, but it's the highest number of times. So hopefully it'll make sense once we get into it a little bit here. So if we look at the first one, what would be the lowest common multiple of 3x times x plus 3 and 6x squared and x minus 3? So we can leave 3x as 3x, or you can separate it as 3 and x. It both means 3x. But that's your first expression. So then the second expression, 6x squared, I like to factor it down to the bare bones. So like instead of leaving 6 as 6, I would factor it to its prime factors of 3 and 2. X squared is x and x. And then we have x minus 3. So when we're looking at this, when I say the highest number of times one factor occurs, when we're looking at this, I see 1, 2, 3 x's. But the highest number or highest frequency that the x occurs in one of the expressions is twice. So our common multiple needs to have 2 x's. So yes, there's 3, but the most that one of the expressions has is 2. So that's going to be the lowest common. And then if you're looking at the numbers, I get that a lot of you guys can probably look at 3 and 6 and understand that the lowest common multiple of 3 and 6 is just 6. Because I factored it out, I'm going to say we need a 3. And we need to include a 2, also known as 6. And then what else do we see that we would need to include in the common multiple? X plus 3 and x minus 3. So we need to include everything that we see between the two expressions. It's just that we kind of have to figure out how many of them we need to include. So let's look at another one. So let's go down here and look at number 3. So 9x cubed and 18x squared, x plus 4. So 9x cubed, 3 times 3. X cubed is x times x times x. And then 18x squared would be 9 times 2. So 3 times 3 times 2. And then 2 x's and x plus 4. So the lowest common multiple of these two expressions, I see a total of 4 3's. But what's the highest frequency or the highest number of times that a 3 occurs in one of them? Twice. So that's what our LCM needs. 2 3's. Okay, so the 3's are covered. Then I see a 2. That needs to be included. So, and again, if you're looking at 9 and 18, what's the lowest common multiple of 9 and 18? 18. What is 3 times 3 times 2? 18. So you guys could write this as 18 instead of the factored form. I just kind of, for the sake of practice, and for when we go to actually do the adding and subtracting fractions, I like to factor out all of them. So then your x's, again, I see 5 total x's, but the most that one of your expressions has is 3 of them. And then we need an x plus 4. So our LCMs will not be this big when we actually go to do the adding and subtracting of fractions, but it's good practice for you guys to get an idea of how to do this. So let's do one more. We'll do number 4. So 4, x squared minus 3x minus 10, and 8 times x squared plus 4x plus 4. So 4, we can go 2 times 2. Again, if you guys understand that the LCM of 4 and 8 is 8, you can just write that down. I'm just going to factor everything. 8 would be 2 times 2 times 2. And then how do we factor x squared minus 3x minus 10? So what multiplies to get us negative 10, but adds to get us negative 3, x minus 5, and x plus 2. How do we factor x squared plus 4x plus 4? Positive 2. So what's the LCM now that all of our expressions are in their factored form? So I see a total of 5 2's, but the highest frequency or highest number of 2's in one of the expressions is 3. So that's what our LCM would need to include. Again, what is 2 times 2 times 2? 8. And then looking at the binomials, what all do we see that we need to include? So I see an x minus 5 and I see x plus 2's. So I know I need that x minus 5 in here. But how many x plus 2's do I need? I see a total of 1, 2, 3. But the most that one of our expressions has is 2. So our common multiple, lowest common multiple, should have 2 of them. Here's the thing. If we just get a random common multiple, it's not necessarily wrong. We can still use it to do what we need to. It's just that you're going to have so much simplifying to do because you're going to have multiplied by so much more than you had to. And when you get your answer, it's not going to be in simplest form because you didn't use the lowest common multiple. So that's why it's kind of important to make sure we're not just multiplying by everything we see, but only what we need. So go ahead and try number 2.